such that p of x is 3 minus 2x cubed, so we type that into our calculator. So we've got 3 minus 2x cubed. Good idea is to define this function. Just define it as f in terms of x. So there's our function, and we want to write down an expression for the inverse of p. And a good way to do the inverse is simply to rewrite it, but instead of y equaling, we just swap x and y. There we go. And solve that, but not with respect to x, with respect to y. And let's go OK. So there's our inverse, expression for an inverse. The power of a third, of course, is just a cube root. If we want to determine the coordinates of the point of intersection, there's two ways to do that. One is to make p of x equal p to the power of minus 1 at x, or we also know that we can find that intersection if we make p of x just equal x. So we can do that here. We can just say f of x equals x, and we solve for that. Then solve, we want to solve it in terms of x, and there's our answer. So the x value of the point of intersection is 1. We know that with inverses, the point of intersection is basically the same, so if x is 1, y equals 1. An alternative way to do that is to get our inverse function, which is this here, and define that. This time we define it as g with respect to x. So we've got f of x and g of x, and we can simply graph those two functions. There's f of x, there's g of x, and we can plot those quite easily on this graph over here. We can find points of intersection too. One easy one is the y-intercept. If we want the y-intercept, it's simply when x equals 0, so that'll be f of 0. Just enter and we get 3, g of 0, and we get the cube root of 3 on the cube root of 2. And of course, because they're inverses, the y-intercept of f will become the x-intercept of g, and the y-intercept of g, which is this, becomes the x-intercept of f. So here it says label any points of intersection. If we look at this blue graph here, it goes through 3, and the x-intercept is going to be the cube root of 3 over the cube root of 2, and vice versa for the inverse. That's the cube root of 3 over the cube root of 2, and that would be 0, 3 there. So that kind of answers question B.